It's the 1st of October, 1942, at the north end of what is now Edwards Air Force Base. A secret airplane is disguised with a phony propeller in case an onlooker wonders why it doesn't have one. It takes off on its first short hop across the lake bed, making a sound new to the Mojave Desert and all of America. It's the Bell XP-59A, the first American jet. The question is, will it be ready in time to have an effect on the outcome of World War II? The Smithsonian Institution's National Air and Space Museum is the most visited museum in the world. Its collection contains some of the most important aircraft and spacecraft in history. Craft that were designed, built, and flown by men and women who have expanded the frontiers of flight. This is the first of the Bell P-59s, designed and produced in extreme haste and secrecy in the early years of America's involvement in World War II. It's on display in the flight testing gallery of the National Air and Space Museum in Washington, D.C. It came about as a result of a deal in which a jet engine that had been designed in England was licensed to General Electric for development in America. The Bell Aircraft Company was given just 6 months to design and build the airframe that would be powered by the engines. The engines were revolutionary. They promised a future with high-speed and high-altitude flight, no more propellers, and a possible military advantage for the Allies over their World War II enemies. This is the story of the Bell XP-59A and its effect on the history of aviation. Begins in England in the years just after World War I. Frank Whittle is a boy who loves airplanes. He leaves school and becomes an apprentice at Cranwell, the Royal Air Force College. His apprenticeship involves him in the study of aircraft engineering, and he demonstrates a natural talent. As he develops his engineering skills, he also throws himself into the theoretical part of his course. He writes a 3-part science thesis called Chemistry in the Service of the Royal Air Force. It includes a study of the atmosphere.
And I became fascinated by finding that at a height of 69,000 feet, the air density was exactly 1/16 of its sea level value. And that meant that it would be possible, theoretically, to fly 4 times as fast for the same drag as at sea level, and get 4 times the lift. But unfortunately, I was rather depressed to realize that it also meant you need 4 times the power. And piston engines wouldn't even turn themselves over at 40,000 feet.
Later, he thinks of putting a piston engine inside a hollow fuselage driving a fan. He rejects the idea, but not completely.
And then I suddenly thought, well, why not throw that piston engine away and substitute a turbine and boost the pressure of the fan? And that was it. That was the turbojet engine.
But there is no interest in the idea. Whittle is now a pilot, known as something of a daredevil. He has some interesting incidents, like this one where his rear seat passenger falls out on takeoff and Whittle has to land with him clinging to the tail. But through all this, he continues to work on and promote the idea of the jet engine.
My brother officers were rather amused by the whole thing. It was known as Whittle's Flaming Touch Hole.
But one of his brother officers was interested and advised Whittle to take out a patent on the idea, which he did.
And then shortly after that, he was sent to Cambridge for advanced engineering work because he'd shown a lot of engineering ability. And in fact, he was brought up in his dad ran a machine shop, and he was mechanically inclined and a good engineer, basically.
While Whittle was at Cambridge in 1935, an old colleague offered to help him get backing for the jet engine. After months of trying, they were successful.
And then in 1937, he formed his own little company, Power Jets Limited. Somebody put up about 10,000 pounds of capital, and he formed his company, even though he was still in uniform. And they let him work part-time on it.
Whittle set up the headquarters of Power Jets in the little English village of Lutterworth. There he began the construction of his first jet engine. After 7 years of development in Whittle's mind, the jet engine was at last about to appear in the flesh. By April 1937, it was ready for testing.
No one believed it would run at all. They didn't think it would even turn itself over. And quite a few people were gathered around to see me make a fool of myself. I was on the controls, and I gave the signal to turn the engine over with a big electric motor we had.
This is a filmed reenactment of what happened at Power Jets on April 12, 1937. At first, everything appeared to operate normally, but then the engine did something quite unexpected.
It accelerated out of control, and so did everyone standing around it. It still accelerated. That was a terrifying thing. I knew that it was going to work, but my impression from that first test is that we had a long way to go.
The problem causing the uncontrolled acceleration was fixed, but Whittle was about to be posted to a location away from his work on the engine. He ran a demonstration for his commanding officers.
The engine ran at least well enough to let the powers that be continue on the job. I was excused my promotion examination to squadron leader and promoted to squadron leader, and placed on the special duty list to continue the work.
In 1938, the director of scientific research, who was skeptical about the engine, came to Lutterworth to see it run. It had now been completely rebuilt twice.
Well, I ran it for 20 minutes at near full speed, and he was at last converted. Decided that we did have an aero engine, basis of a practical aero engine, and agreed that a flight engine should be ordered and an experimental aeroplane to test it.
But the world was changing rapidly. In September 1939, Hitler's blitzkrieg began in Northern Europe. War in Europe, long a possibility, was now a reality. And Britain, like many other nations, wasn't ready. In early 1940, the Whittle W1 engine was thought by some in the military to be a potential war winner. But complete recognition was still a long way away. At this time, Britain's air resistance to the German Luftwaffe depended on Hawker Hurricane and Supermarine Spitfire fighters, very much on a par with the German Messerschmitts in performance. Britain could have used a weapon capable of flying 500 miles an hour at more than 40,000 feet. By April 1941, the Gloucester-Whittle E-28 was ready for taxi tests. Frank Whittle himself was in the cockpit for some of the trials, but even then there was little official interest in the first flight.
Certainly no important official had turned up to see that first flight, and they refused our request for an official photographer. And such rather poor film that exists was done by a handheld camera of someone from the Gloucester Aircraft Company.
On May 15th, Flight Lieutenant Jerry Sayer was in the cockpit.
Jerry went to the end of the runway, and we stood about a couple of hundred yards along by the side of the runway, and then he took off. It was quite unsensational. He took off beautifully, and he left the ground in about 600 yards, disappeared into the clouds, and we didn't see him for about 15 minutes, but we could hear him.
It was a triumphant success, but its potential was still not recognized. A strange thing happened.
Our priority was taken away because they said everything must go into Spitfires and Hurricanes and so forth.
Again, Whittle was bitterly disappointed. He wanted the engine taken somewhere safe for development.
Hap Arnold, the U.S. Air Force general, got wind of it, you see, and he made a deal with the ministry.
They sent word over to General Arnold that they had a project that could conceivably affect the outcome of the war, and asked him to send a technical team over to evaluate it.
The evaluation was positive. In great secrecy, details of the engine were passed on to General Electric with the object of building a test model and then producing the engine in America. General Electric was chosen because of its experience with turbines, a technology closely related to the needs of Whittle's jet. GE accepted the job and, in a highly secret operation, took delivery of a Whittle engine on which to base its own production version. Secrecy was also the key word at Bell Aircraft, where a special isolated unit was set up to build America's first jet airplane.
Bell was selected as the contractor to build the airplane because they'd shown a lot of innovative capability, and they had the capacity to take it on. The other builders of fighter airplanes were really loaded to the gills. Another reason for giving it to Bell was because Larry Bell was there to personally ride herd on the program.
On December 7, 1941, the stakes were raised. Japan bombed Pearl Harbor, and America entered World War II. At General Electric, a secure unit was set up to test the engine when it was finished. It was appropriately named. But engine manufacture wasn't concentrated in one place. Different parts of the engine were given false part numbers and manufactured at different locations in the factory. The GE workers didn't know they were building America's first jet engine. Only the final assembly of the parts was performed behind closed doors. The engine that emerged from the secret process was called the General Electric Type 1A. It was designed to produce 1,250 pounds of thrust. While GE was building its engine, Bell Aircraft was dealing with the task of producing a new jet airplane from scratch to completion in 6 months. Since it was top secret, they couldn't even use government wind tunnels. Only one model was made before the design was laid out on the floor and production began. As another secrecy measure, Bell's jet was given a misleading designation. Bell had abandoned a project for a piston engine fighter called the P-59. The new jet was to be called the XP-59A. This is Edwards Air Force Base in the Mojave Desert north of Los Angeles. Today, it's the center of Air Force flight testing, but in 1942, it was just desert.
The site was perfect for testing top-secret aircraft because it was so far away from everything. The lake bed was the other major factor because it provided a vast expanse of runway in any possible direction. in case an airplane, in this case a jet airplane, as with the P-59, flamed out, the pilot could make a dead stick landing from almost any position around the lake bed. When the decision was made to locate the P-59 test program here at Muroc, there was nothing here in terms of test support facilities. And the need for security, this was after all a top secret program, dictated that the test site should be at some distance from the training base that existed here at that time. For that reason, they selected a site on the north shore of the lake bed.
Today, that same site, known as North Base, houses some of the Air Force's most secret test projects. But in 1942, when Bell Chief Test Pilot Bob Stanley came out to Muroc Dry Lake to prepare for the secret jet tests, he started with very little.
The barrack was more or less completed. The water tower was completed. The hangar was not completed. It was a portable hangar which had lost a few of its parts along the way. And when Bob Stanley arrived, the place was a top secret site. They had to get rid of the construction crew. So Bob Stanley had to oversee the final construction of the hangar and the barrack. Now this included, among other things, all the electrical system. And Bob Stanley had quite a reputation amongst his fellow workers as being, first of all, a brilliant engineer, very fine test pilot, very hard driving man, difficult man to work for, but brilliant. He seemed to know a little bit about everything.
In mid-September 1942, the first Bell XP-59A arrived at Muroc. It had come out to the desert by train from Buffalo, securely wrapped to preserve its secrecy. It was unloaded, taken the last few miles to North Base, and assembled. The group working on the plane at North Base was made up of representatives from Bell Aircraft, General Electric, and the Army Air Forces. Before the end of the month, Bob Stanley was satisfied that the engines could be fired up for their first tests in the aircraft. So little was known about the behavior of jets that paint strips were applied to the fuselage near the jet exhaust to test the effect of heating on the skin of the airplane. Crew members weren't sure just how close to the jet exhaust you could stand with safety. They found the skin was not unduly affected by heat, and if you were careful, being around jets was not too different from working near conventional aircraft. The engineers from General Electric watched anxiously. They were dealing with temperatures much higher than those in piston engines. They had to make sure the new jets lasted. By the end of September, Bob Stanley had run a series of taxi tests with satisfactory results. He was now ready to see how America's first jet airplane would behave when it left the ground. Early on the morning of October 1st, 1942, the XP-59A was wheeled out of the hangar for its first flight. The plan was conservative. The first venture off the ground would just be a low-altitude hop, and if it went well, Bob Stanley would make more flights at increasing speeds and altitudes. In some ways, the cockpit layout of the new jet was simpler than that of a piston-engine airplane. There were fewer instruments to monitor engine performance. On the left side of the cockpit, there were two throttles, one for each engine. As Bob Stanley sat in the cockpit of the XP-59A that October morning in 1942, he could not begin to imagine the impact the jet engine would have on aviation and the world in the next few years. His mind was on the next few minutes in an untried airplane. On the first hop, The maximum altitude was 25 feet, and the landing gear stayed down. The next day, the ceiling was raised, and so was the curiosity of the people at South Base.
The combustion on this first engine was not very good, so there's heavy black smoke trailing behind it. It's particularly noticeable if you happen to be looking up the column from the back. From the side, you could see it, but if you were looking up that column, it really looked bad. And Bob hadn't been in the air more than 2 or 3 minutes, and the telephone rang, and we got a call from the South Base. And this excited voice said, do you want some help? Can you send the fire people up? Walt said, no, what do you mean? Well, you got an airplane on fire. And, and he realized what it was. No, I think we can handle it all right. So then the guys, and they knew we had a bunch of nuts up north if they took an airplane on fire that carelessly.
Apart from that, the flights of October the 2nd, 1942 were a success. Bob Stanley made 4 of them, reaching a maximum altitude of 10,000 feet. After only 3 hours running time on the engines, the flight test program came to a halt.
And then we were running into a 3-hour limitation that GE imposed so they could, because of course the engine was far more experimental than the airframe. And after 3 hours of running, it's run-up time, taxi time, flight time, they insisted they must pull the engines out of the airplane, partially disassemble them, and inspect key parts for the effect of temperature and wear, which is all very, very logical.
Even though North Base at Muroc was very isolated, it wasn't completely secure. There was a road fairly close by, running from the small town of Boron down to South Base.
With a road running by about just half a mile away from us in that clear desert air, a lot of mechanics lived at Boron, working down at the South Base, so they were going back and forth every day. Some of those individuals were bound to be propeller-oriented, and they were going to notice that there was no prop on this airplane, so we rigged up a little round ring with 4 balsa wood blades going out in 4 directions. So whenever the airplane sat outside the hangar, that was just stuck on the nose, so that anybody half a mile away, it took care of that emergency before it arose.
By the time the engines were ready to go again, Muroc Dry Lake had become flooded, and the testing program was moved briefly to drier ground. Again, the phony propellers were brought into service. The honor of making the first test flight for the military fell to Lawrence Craigie almost by default. 2 other pilots who would have preceded him were overseas at the time.
I did it more just in a normal matter of course, because I'd been living with the program all year, and was very close to all aspects of it. So with Swafford and Kern in England, it was the most natural thing in the world for me to be out there and be bossing the program from the Air Corps side.
Half a century later, his recollections are vivid.
In an ordinary airplane with a piston engine, the moment of takeoff is the moment of maximum vibration. And with this rotary device, and only operating at half power, it was very, very smooth. So as we broke ground and took off, it was just amazing, that feeling of quiet. So that was the impression I've always carried with me of that first flight. It was accentuated, of course, by the fact that we were only operating at half power. Again, GE's conservatism.
General Electric specifications had promised 1,250 pounds of thrust per engine, giving a total of 2,500 pounds. But it was clear to those who flew the airplane that the engines weren't producing nearly that much. Lack of power became an issue.
We were a little bit concerned. We thought they were being a little over-conservative. We wanted to know just how much thrust we were getting, so Bob Stanley had him stick a metal fence post in the lake bed, and we got a big spring scale, and we attached it between the fence post and the airplane, and we revved the engines up as high as GE would let us go, and we got a reading of 1,600 pounds on that spring scale, so we were getting 800 pounds of thrust per engine, which is not a hell of a lot.
In fact, it wasn't much more than half what had been promised, and lack of power meant lack of performance. The secret flight test program continued from South Base at Muroc Dry Lake. With new pilots being introduced to the XP-59A and more flights being made, it became harder and harder to keep the project hidden from inquisitive eyes.
One of the gunnery students, the South Base, happened to be just taken off, and he saw a P-59 taking off up north, and he noticed this heavy cloud shadow on the lake bed following it, which got his attention. Of course, it was from this cloud of smoke behind the exhaust. And then as the airplane got in the air, he decided that he was going to get a look at it in spite of the instructions he'd had to leave it alone. So he maneuvered his airplane so that he got pretty close to it up in the air, and he saw it had no prop. So then he got all excited, and when he landed, and he told all of his buddies back there that he'd solved the mystery, that airplane didn't have a propeller. And they literally laughed him out of it, because it wasn't possible for an airplane to fly without a prop.
These new jet engines were very temperamental. It was a totally new technology. And the early engines were subject to flameouts, frequent flameouts. There was no way to restart the engines in flight. And hence, if you lost your engines, you needed a place to land and land quickly. The lake bed offered this opportunity to land in any direction, as long as you were flying within the vicinity of it.
It became evident that it was a very short-range affair, and this is where that unlimited expanse of lake bed paid off up there, because they thought nothing of just running a test until they ran out of gas. Stop, and they'd make a dead stick landing. In other words, just come in and land on the lake bed. They did this several times. Although it was not a dangerous airplane to fly, its handling characteristics were perfectly satisfactory, but it wasn't really a stable airplane, and it didn't come up to the performance handling qualities of an airplane like the P-38, the P-51, or the P-47.
There were many minor problems with the XP-59A, some very uncomfortable in the desert heat.
Temperatures in the cockpit were very high, and the reason for it was that the Bell had designed a double glass canopy with provisions to pipe hot gas from the engine compartment up in there to de-ice the winter and to keep it from frosting over. But the valve, which was supposed to be able to control it, wasn't functioning properly, so whether they wanted it or not, the hot air was coming through there all the time.
Tex Johnston was a company test pilot with Bell. His job was to make altitude tests.
I was testing the airplane stability and control performance in 5,000-foot increments up to ceiling altitude, and everything was going well. And when the Wright Field back at Dayton, the Air Force, got the data from the 30,000-foot flight, which has made propeller airplanes obsolete, you know, they said, go immediately to the ceiling. And I got to 46,000 feet, and the rate of climb was, I estimated, down to just 100, maybe 100, 150 feet a minute. So I said, that's it, that's the altitude, and that's 46,600 feet. And I stabilized out and recorded the data. And then I pulled the throttles back to start the let down, pulled them clear back to idle, and they still ran at full bore. And I could drop the nose just a few degrees, and I'd get into high-speed buffet. I'd pull it up and go a little bit too slow, and I'd get a low-speed buffet, which is stall warning, high-speed stall, low-speed stall. And I Of course, I could only estimate this, but from my experience, I knew that I had about a spread of about 35 miles an hour between high-speed stall and low-speed stall.
Tex's solution was to cut one of the engines, making sure it wasn't the one that drove the hydraulic systems.
With one engine shut down, it decreased the thrust 50% so I could let down, and I was in high-speed buffet all the way until I got down to about 35,000 feet.
Very few people knew of the existence of the plane, but most of those who did wanted to fly in it.
In the portion of the nose of the airplane that would house the armament section, the guns and ammunition and so forth, they installed a little cockpit just for an observer. And I've always felt that the primary reason for that really was to let Larry Bell fly in his airplane, but of course it meant so much to him personally that his company had produced the first jet in this side of the world.
Larry Bell realized his ambition. He sat in the outside cockpit and became one of the very first jet passengers in the world. You can just see a flying helmet above the front of the fuselage. Larry Bell was only one of a number of VIPs who were impressed by a flight in that very unusual jump seat. Tex Johnston was given the job of taking a dignitary from Washington on the flight. He chose a route along the highway to Boron.
And so I took him down this highway at full bore, right about 10 feet off the deck, you know, so he's looking up the telephone post. And when he came back and landed, he got out and he said, "God damn, this son of a bitch went down the road and the telephone line looked like a picket fence."
Performance on flight tests wasn't the leap forward that had been hoped for.
I guess we really weren't disappointed until we got well into the program when we realized that it just wasn't shaping up. We didn't begin to appreciate in the early days what a tremendous breakthrough it was going to be.
But on the other side of the Atlantic and the other side of the war, the potential of the jet had already been recognized. The world's first jet airplane, the German Heinkel HE-178, had flown back in 1939. But the real German threat was built by the Messerschmitt Company and entered service in mid-1944. By late that year, Allied intelligence officers were seeing unusual signs in reconnaissance photos. Frank Whittle, Britain's jet pioneer, was called in to help.
I saw the photographs and was able to help interpret them. And they were plain enough with the double scorch marks of a twin-engine jet.
Those marks were made by the Messerschmitt Me-262, the most famous and successful German jet of the war. As early as 1938, Messerschmitt had been asked to submit a design for a fighter powered by 2 turbojet engines. German jets were then in the early stages of development, and when the Me-262 was ready to fly in early 1941, the engines designed to power it were not. It made its first flights with piston engines and didn't fly under jet power until July 1942. Pilots who flew the 262 for the first time experienced an enormous leap in performance over piston engine fighters. It had excellent handling qualities and high speed. But the Me-262 didn't enter service until July 1944, almost exactly 2 years after its first test flight. By that time, the war was going badly for Germany, and Allied air power was so dominant that the small number of 262s in combat could make little difference. The German Luftwaffe had not developed tactics to make full use of the 262's high performance, and there was no real plan to deploy it effectively. One of the tantalizing what-if questions of World War II is what if the 262 had been brought into service earlier than it was? Would it have affected the outcome of the war?
There were delays in that program which are a little hard to explain later on, some of which were due to Hitler himself injecting himself into the program and decided that he wanted him to build bombers instead of fighters. So that delayed the program probably 6 months. Even so, they did succeed, even in spite of all the difficulties they had in Germany with the war going against them. They built 1,200 of those airplanes. And fortunately for the Allies, only 200 of them ever saw service.
In war-ridden Germany, it took a long time to develop the jet engine to operational standard, and there were other reasons for the delay.
They were the successful airplane. See, they had logistic problems. They had pilot problems, and they had fuel problems, and they had logistic problems getting to use these airplanes, which is why they never used but 200 of the 1,200.
In the Mojave Desert in 1943, Bell Aircraft was having problems of its own in fulfilling the promise offered by jets as a weapon of war. There were now 3 prototypes of the Bell XP-59A under test. They had been developed in extreme secrecy and isolation, without the benefit of normal design processes available to most advanced aviation projects in America. Even now, after months of flight testing in the desert, Bell and General Electric were very much on their own, continuing to fine-tune the engine and airframe in isolation.
As the program developed, we wanted to give Bell some outside help. In fact, the normal thing in an experimental program would be for the airplane manufacturer to work with the NACA, utilize NACA's wind tunnels at Langley Field. But they were not allowed to do that. In fact, NACA knew nothing about this program. There probably weren't over a dozen or 15 individuals at Wright Field that knew of the existence of the program until long after the airplane flew.
In 1943, Larry Bell had a problem. He'd been forced to develop America's first jet airplane in secret and make all the mistakes that others could capitalize on in future. Now he had to try and secure some long-term benefit for his company. Before the prototype had flown, Bell had received a production order for 13 additional planes designated YP-59A for Army Air Force's service trials. As they became available in 1943, early impressions were confirmed. The potential of Bell's new jet as a war winner, or even as a war participant, was not great. In January 1944, the silence was broken. The fact that America had a jet airplane was made public. For months, the Bell Company had been trying to convince the military to buy a large production run of the P-59. In mid-1943, Larry Bell had suggested to the Army Air Forces that they order 300 airplanes. He tried as hard as he could to sell the Army and the Navy on the value of the plane for the war effort. Bell Chief Test Pilot Bob Stanley flew a series of demonstrations for military personnel. Only a handful of people had ever seen a jet fly before. For almost everyone here, it was the first time they had seen a plane fly without a propeller, and the first time they had heard the roar of a jet engine. Unfortunately, in spite of the novelty of jet power, it was all too apparent that the P-59 was not enough of an advance on the best of the Allied piston engine fighters to justify a large production run. Eventually, the Army ordered 100, but only about half of that number would ever be built. General Electric continued development on the turbojet engine, knowing that it would have a future independent of the success or failure of the P-59. But for Bell, it was becoming apparent that their first American jet was not going to be a runaway success. Other manufacturers were already biting at Bell's heels. In early 1943, while Bell was still turning out its 13 YP-59As, Lockheed had been invited to submit a design for a single-seat jet fighter. As the production run of P-59s began to roll out of the Bell factory at Buffalo, more and more people in the services came into contact with them on a daily basis. But it took a long time for the news of this revolution in power to filter through to those still fighting on remote overseas battlefronts.
I didn't know a thing about it, and none of the pilots did. In fact, I recall when there was a magazine called Impact. It was an intelligence magazine that was circulated in the Air Force. And I remember sometime in 1944, toward the end, I saw a copy of it and had a picture of a P-80 in it. And I thought they were just, trying to fool somebody.
In England, development on the jet engine had been proceeding independently. A new airframe had been produced by the Gloucester Company, powered by 2 jets. It was called the Gloucester Meteor, and its performance was very impressive. The Gloucester Meteor came into service late in the war. It was fast enough to chase and catch the German V-1 flying bomb. British pilots developed a special technique to deal with it. Shooting it down was dangerous for a pilot who had to fly through the explosion. But if he could position his Meteor's wingtip under the V-1, he could tip it off balance so it would fall out of the sky. Back in the USA, as the war approached its end, more and more young pilots began to experience the feeling of flying an airplane without a propeller. 20 P-59As and 30 P-59Bs went into service. But they were not destined to enter combat or to have any influence on the outcome of the war. Instead, they were used to familiarize pilots with the handling and performance of jet aircraft.
The P-59 was sort of the first jet and a good one to transition into by people who have flown conventional airplanes. And that's more or less where it stayed. It never was built for a combat airplane. It was a very easy airplane to fly, a very pleasant one, but it didn't have striking performance. Very short-legged, could have used more fuel. You had to be careful with fuel control. The fuel controls were not adequate, and you stayed away from sudden bursts of the throttle because you might have a flame out.
Don Lopez, back from service in China flying P-40 fighters, got his chance in a P-59.
I was really excited to get to fly a jet because there were very few of them. And I remember it had such a big wing, a tremendously big wing from fore and aft, a lot of chord. And it seemed like you were stepping down into a bathtub or something into the cockpit. But when you started the engine, you just pushed the button and one engine started, then you pushed the other, and you could almost only tell it by the instruments. There was hardly any noise. And you had to give it almost full throttle to get it to taxi, to move. And when you lined it up with the runway then, and you didn't have to warm up or check your engine. If it's running, it's running. And you line up with the runway, give it full power, and let go of the brakes, and hardly anything happened. Then you just gradually start moving down the runway. It felt sort of like you were being towed by an invisible tow plane. And it lifted in the air because it had a lot of lift with the big wing. And it handled all right. It wasn't terribly fast. It was maybe a little faster than a Mustang, but and you could only stay up about 30 minutes because it ran out of fuel. But just being a jet was very interesting. But it didn't handle that well like a real fighter.
But already there was a new U.S. jet operating that was just like a real fighter. In fact, better than any fighter that had ever flown in America. Its performance and handling qualities far exceeded those of the Bell P-59. It was the Lockheed P-80 Shooting Star. Although this prototype was built in only 143 days, and flew for the first time on January 8, 1944. The P-80 was too late to have any impact on the war.
At the end of the war, we had one P-80 in Italy and one P-80 in England. As a morale factor for our pilots who were running into 262s, and what are we doing?
In 1946, the first national air races since the start of the war were held. Huge crowds enjoyed the opportunity to see some of the enormous advances in aviation from the war years. The P-80 was one of the stars of the show. It was exciting to watch and to fly.
My first flight in the P-80, I literally felt when we got off the ground in the air as if I was literally 6 or 8 feet behind the airplane trying to catch up with it, because it had that tremendous thrust.
I loved it. It handled very well, very maneuverable, very small, tight cockpit. You really felt like you were in a fighter, and it just was you climbed at 380 miles an hour, which was about 180 miles an hour faster than the P-40 cruised, and it just was a great airplane. I liked it very much. You felt like you belonged in it when you first got in it.
Immediately after the war, captured German aircraft were flown into France as part of Operation Lusty. Among them were many Me-262s, not all of which were recovered with complete success. These airplanes were then shipped to America and put through a testing program. Rush Schley flew an Me-262.
Performance-wise, it was a great airplane. It had great flotation. You could land on unprepared runways. Oddly, it had a nose wheel brake as well as the main wheel brakes, so you could get it stopped in a hurry. It had great firepower, devastating firepower, with the 4 cannons in the nose. It had long range. The shortcomings were it had 20-hour engines. We'd have to change the engines after about 20 hours.
So in 4 years since the XP-59A was rolled out in secret in the Mojave Desert, it had not achieved as much as other early jets. What then is its significance in the history of aviation?
Had the airplane been developed in the normal fashion, with all of the wind tunnels of NACA and all of the capabilities of NACA and the Air Force available to it, a lot of these things would have been discovered and would not have existed in the airplane. So it was not a successful military airplane, but it was the beginning. It was the first jet in this country, and Bell truly did a remarkable job under almost unbelievably difficult circumstances with the security and the other hamstrings that they were subjected to.
One of the great ifs of aviation is the question of what would have happened if the British authorities had supported Frank Whittle's jet engine concept in the early 1930s, soon after Whittle came up with the idea. Sir Frank Whittle himself has no doubts about the answer.
Oh, if the whole thing had been backed as early as it should have done, it might have been in service 5 years earlier. And von Hayne, the German jet engine man, he's publicly said 3 times that had the British government backed me, as it should have done, it might have stopped World War II.
Whether or not that's true, Frank Whittle and his jet engine have had a profound effect on the history of aviation.